Hi guys, welcome to my YouTube channel Physics Prince. Uh, I'm going to teach you all 9 subjects of physical science in detail. My course is going to help the students who are preparing for CSIR-NET, GATE, NT exam, PhD exam, SET exam and other exams related to physics. And guys, my courses are absolutely free of charges and I'm going to take 3 classes every day. I'm going to teach quantum mechanics and mathematical physics in first 2 classes, and in third class, I'm going to uh, solve CSIR-NET PYQs. Okay, and also, guys, I would like to thank you everyone who has supported me and subscribed my channel. Because of you guys, I'm eligible now taking live classes. So guys, and also I would request the people who have not subscribed my channel, please subscribe my channel. Okay, so today we are going to solve quantum mechanics PYQs. Okay, and I'm going to start now. I hope guys I'm audible, because last time I was not audible, and because of that I had to end class many times. Okay guys, so we're going to start with questions. And I also apologize for the I apologize, actually the last time the voice was not audible, so I apologize for that. There was technical error. Now it is fixed, and so we are going to start with question number 1. Okay, the question is the wave function of a particle, the wave function, the wave function of a particle is given by is given by psi equal to 1 upon root 2 phi 1 plus iota phi 1. It's phi 0 actually. Where phi 0 and phi 1 are phi 0 and phi 0 and phi 1 are the normalized eigenfunctions normalized eigenfunctions with energies E0, E0 and E1, E0 and E1 corresponding to the ground state ground state and first excited state respectively, the expectation value of the Hamiltonian expectation value of the Hamiltonian in the state psi is wait, let me write down this again. Expectation value of the Hamiltonian in the state psi is okay. Okay. Options are option number A, E naught by 2 plus E1, E naught by 2 plus E1. Option B is E naught by 2 minus E1. Option C is E naught minus 2 E1 upon 3, and option D is E naught plus 2 E1 by 3. Okay. So this is the question. Okay, there is some technical error I'm getting in YouTube. Let me just fix it. Okay, guys. So the question is the wave function of the particle. We have been given wave function of the particle, that is psi equal to 1 upon root 2 phi 0 plus I phi 1, where phi 0 and phi 1 are normalized eigenfunctions with energies E0, E1 corresponding to ground state and first excited state respectively. The expectation value of the Hamiltonian in this state psi we need to find out, right? So we need to find out expectation value of Hamiltonian. We know that is psi h psi upon psi into psi. Okay, this is the expectation value. Okay, since we have been given that psi is 1 upon root 2 phi 0 plus iota phi 1, right? So we can easily found this brass psi, that is going to be 1 upon root 2 phi 0 minus iota phi 1. Will replace iota by minus iota for getting bra vector. Okay. Okay, so now the expectation value of Hamiltonian is going to be 1 upon root 2 phi 0 plus iota phi 1 into Hamiltonian 1 upon root 2 phi 0 minus iota phi 1 upon 1 upon root 2 phi 0 minus iota phi 1. So just wait. This is going to be minus and this is going to be plus. Okay, I phi 1 into 1 upon root 2 phi 0 plus iota phi 1. Okay, so we'll solve it. It is after solving this, it is going to be 1 upon 2. I'll solve it for you. Okay, 1 upon 2 phi 0 minus iota phi 1. We'll operate h with this, so it is going to be 1 upon root 2 E0 E0 phi 1 phi 0 plus iota E1 phi 1 after operating Hamiltonian with this. Okay, upon this is going to be, will operate it and it is going to be 1 upon 2 plus 1. Since we know phi 1 and phi 2 are normalized eigenfunctions, right? So it means phi 0 with phi 1, this product is going to be 0. Similarly, phi 1 with phi 0, phi 1 with phi 0, this is going to be 0. And phi 0 with phi 1, this value is going to be 1. Similarly, phi 1 with phi 1, this value is also going to be 1 because phi 0 and phi 1 are normalized wave function. Okay, in next, the Hamiltonian value is going to be, expectation value of Hamiltonian is going to be will will simplify it further. So it is going to be, this is 1 upon root 2, okay, this is also 1 upon root 2. It is going to be 1 upon 2 E0 plus E1 upon 3 by 2. So Hamiltonian H is going to be E0 plus 2E1 upon 3. Okay, so this is the answer for this question. Now we'll check the options. So which option is correct? Which option is matching? So option D is matching, right? E0 plus 2E1 upon 3. So E0 plus 2E1 upon 3. So this is the first question. Okay, now we are going to solve next question. This is also a very good question. Okay. We will solve this in next page. Question number 2. So this is the energy levels of the energy levels of the energy levels of the non-relativistic electron of the non-relativistic electron non-relativistic electron, the energy levels of the non-relativistic electron in hydrogen atom, in hydrogen atom that is in a Coulomb potential, in a Coulomb potential, which is given V, which is function of R proportional to 1 upon R minus 1 upon R are given by ENLM proportional to minus 1 upon n square, where n is the principal quantum number, n is the principal quantum number and corresponding wave function the corresponding wave function wave functions are given by psi NLM where L is the orbital where L L is the orbital angular momentum quantum number angular momentum quantum number, and m is the magnetic quantum number, the spin of electron is not considered. Okay, the spin of electron isn't considered, Which of the following is correct statement? Which of the following is correct statement? Okay. Options are just let me check it. There are exactly 12 plus 1 different wave functions for each NLM. For each ENLM. Option B is there are L into L plus 1 L into L plus 1 different wave functions for each ENLM. Okay, next option. Option C. This is ENLM, that is ENLM does not depend on L and M for the Coulomb potential. For the Coulomb potential. For the Coulomb potential. Option D is there is a unique wave function. There is a unique wave function psi NLM for each ENLM. For each ENLM. Okay, so this is the question. Okay, I'll read the question. The energy levels of non-relativistic electron in hydrogen. Okay, so we are talking about energy levels of non-relativistic electron in hydrogen. Okay, that is in Coulomb potential, which is in Coulomb potential. Okay, that is VR proportional to minus 1 upon R is given by ENLM, that is energy level is given, right? ENLM proportional to minus 1 upon n square, where n is the principal quantum number and the corresponding wave functions are given by psi NLM. Okay, where L the orbital angular momentum quantum number, m is the magnetic quantum number, the spin of electron isn't considered. So we are not considering the spin of electron. Okay, which of the following is the correct statement? On the basis of that, we need to find out the correct statement. Okay, so here energy eigenvalue, that is energy levels, is given, ENLM is given proportional to minus 1 upon n square, where n is the principal quantum number. Okay, so we'll check one option by one. Okay, so the first option is given, there are exactly 2L plus 1 different wave functions for each NLM, right? This option is not correct. Second option is there are L into L plus 1 different wave functions for each NLM. This is on. This is also not correct because we don't have any information regarding it, right? But now check the option number C. Option number C is saying E and LM does not depend on L and M for the Coulomb potential. This is absolutely correct because here we can see that E and LM is only proportional to minus 1 upon n square, means it is only uh, depending on principal quantum number, right? So it is so there is no other term apart from principal quantum number. So the option number C is the correct option, that is E and LM does not depend on the L and M for the Coulomb potential, the potential which we have been given, that Coulomb potential. Okay, and there is a unique wave function phi and LM for each. This is also not correct. So option number C is the correct option. Very simple question. Okay, so I hope you understood this question, guys. So now we are going to solve next question. Okay, this is also very important question. We are going to solve question number 3rd. This is the Hamiltonian of an electron the Hamiltonian of an electron, the Hamiltonian of an electron in a constant magnetic field B, in a constant magnetic field, B is given by H equal to mu into sigma dot vector B. Okay, Hamiltonian is given where mu is a positive constant, and sigma equal to sigma 1, sigma 2, sigma 3, sigma 3 are Pauli matrices, okay, let omega equal to mu b upon h cut, and IBD 2 cross 2 unit matrix. Then the operator e to the power I e to the power iota h, that is Hamiltonian, t ht upon h cut simplifies to options are given. Option number A, iota cos, sorry, this is I, the unit matrix, okay, identity matrix, sorry. So it is cos, iota cos omega t by 2 plus iota sigma dot b upon b sin omega t. Option B is iota cos omega t plus iota sigma dot b, iota sigma dot b upon b sin omega t. Option C is iota sin omega t plus iota sigma dot vector b upon b cos omega t. Option D is I sin 2 omega t, I sin 2 omega t plus iota sigma dot b. Okay, so these are the options which are given. This is very good question. Okay, so I'll read the question. So the Hamiltonian of an electron in a constant magnetic field. So Hamiltonian is given of Hamiltonian of electron is given, which is in constant magnetic field B, that is H equal to sigma 1, sigma 2, sigma 3, that is sigma x, sigma y, sigma z, we can also say, are polymatrices. We know the polymatrices, right? Let omega equal to mu b upon h cut and I be the 2 cross 2 unit matrix. Okay, that is unit matrix or identity matrix. Then the operator e to the power I iota ht upon h cut simplifies to. So we need to find out the value of e to the power iota ht upon h cut, right? Which that we need to find out. Okay, so it's very good question, and we can easily solve this question by the formula. I'll help you for this. Okay, so here is a formula which you need to note down and also memorize it. Okay, so it is, we know, is a formula e to the power iota sigma dot n cap theta. The value of this is always iota cos theta plus iota sigma dot n cap sin theta. So this is the formula, guys. If you know this formula, you can easily solve this question. Okay, the formula is e to the power iota sigma dot n cap, where n cap is a unit vector, theta equal to I cos theta plus iota sigma dot n cap sin theta. Okay, so now we have been given Hamiltonian H equal to mu into sigma dot b. Okay, so Hamiltonian is given H equal to mu into sigma dot vector b, which is given whatever we have been given in question, and write those things. Okay, so then it will make, then you can easily understand the question and you can easily solve the question. Okay, okay, and what else is given? That is omega is given, omega is given, and omega is given, these are given. Okay, in the question, omega equal to mu b upon h cut. Okay, mu b upon h cut, and we know theta is omega t, right guys? This is also given. What else given? Let me check. And sigma is a polymatrix, which is also given. Okay, okay, so now we are going to solve it, right? So we have to find value of e to the power iota, right, e to the power iota h ht upon h cut. Okay, h is Hamiltonian, ht upon h cut we need to find out, right? So we'll try to we'll make this, we'll convert this form into this, and then we'll apply this formula, and easily this question will get solved. Okay, so we'll put the value. So e to the power iota, value of Hamiltonian is given, that is mu into sigma dot vector b. Okay, uh, t upon h cut, right? Since we know we have been given vector b is mod of b into b cap, right? So it implies we can write b cap equal to vector b upon b. B is the mod, right? This we know. So we'll put the value. Next page we are going to do. Okay, so it is going to be e to the power iota. So here, so in place of b vector, we can write mod b into b cap, right? We can write it. Okay, so iota iota mu in place of b we are going to write b into b cap, right? We can write Any vector is equal to mod of vector into its direction. We know it, right? Okay. It is going to be mu b into sigma dot b cap, okay, into T upon H cut, right? So it is going to be e to the power iota, and the mu b upon H cut we have been given. Mu b upon H cut is given omega. So in place of mu b upon this H cut, we can write omega and sigma dot b cap into T. Into T. So we can write implies e to the power iota sigma dot b cap into omega t. So now this becomes in the form of this one, right? E to the power iota sigma dot n cap into theta, because theta is omega t, right? So now we can easily use this formula because this is the because this is in the this same form, right? So now we'll use the formula. So it is going to be iota cos omega t plus iota sigma dot b cap sin omega t. This formula we have used, right? This one, e to the power I iota sigma dot n cap. N cap is a unit vector. Theta equal to iota cos theta plus I sigma dot n cap sin theta. So we have used this formula. We have made first this into this form, and then we have used this formula. So it is going to be now iota cos omega t plus, again we can write value of b cap, vector b upon b, right? So it is going to be iota sigma dot vector b upon b into sine omega t. So it is going to be iota cos omega t plus, this is I cos omega t, okay? It's unit matrix, identity matrix. Iota sigma dot vector b upon b sine omega t. Okay, so this is the answer. So now we'll check which option is matching. Which option is matching? Iota cos omega t. This option B is matching. Okay, option B is matching. So this is the correct answer. Option B, iota cos omega t plus iota sigma dot vector b upon b sine omega t. That is option number B. So you can solve this type of question easily, but you should remember this formula. It's note down this formula, guys. Very important formula. Okay, e to the power iota. I'm emphasizing this formula because it's a very important formula. Okay, so e to the power iota sigma dot n cap theta equal to I cos theta plus iota sigma dot n cap sin theta. So we have used this formula and solved this question very easily. Okay. Okay. So now we are going to solve question number 4. Okay, so question number 4 is, these are quantum mechanics PYQs we are solving. Okay, so if the perturbation related question, if the perturbation pertur- if the perturbation h dash equal to ax, where a is constant, a is constant, is added to is is added to is added to the infinite square well, potential, which is given Vx, which is the function of x, equal to, it's one dimensional infinite square well potential. Okay, 0 for if x is between 0 to pi, and infinite otherwise. Okay, the correction to the ground state energy, the correction the correction correction to the ground state energy to the first order, to first order first order in A, first order in A is, options are given. Option number A is A pi by 2, A pi by 2. Option B is A pi. System got hanged. Okay. Option B pi is A pi. Option C is A pi by 4, A pi by 4. Option D is A pi by root 2, A pi by root 2. Okay. So the question is, if the perturbation is given. Okay, if the perturbation h dash equal to ax, okay, where given, and where a is the constant, and is added to the infinite square well potential, and that perturbation is added to infinite square well potential, whose square well potential Vx equal to 0 for if x is between 0 to pi, then its value of potential is 0, else infinite. Okay, the correction to the ground state energy to first order in A we need to find out, right? First order correction in ground state we need to find out, right? So we'll solve it first, and then there is a trick as well. So I will tell you trick as well. Uh, so you can solve it by trick as well as we solve it normally. Okay, first we'll solve it. Okay, so it's one dimensional infinite potential. Just wait, just give me 1 minute. I'm just fixing something. Okay, so we know the wave function for one dimensional infinite potential well, right? So the wave function we know, that is psi equal to, this is the wave function. This is the one dimensional potential which is given. It's infinite. Okay, 0 to pi which is given, right? So we know 0 to a, that for 0 to a we know that is root 2 upon a sine, for one dimension it is going to be sine pi x upon a, or we can use L as well. So I'm writing L actually. Pi. So wave function is psi equal to root 2 upon pi sine pi x upon pi. Pi will get cancelled, so it is going to be psi equal to root 2 upon pi sine x. Okay, so psi star is going to be same because there is no complex number, so it is going to be 2 upon pi sine x. Okay, so this is the value of psi and this is value of psi star. So we need to find out the first order correction in ground state, right? So E01 first order correction in ground state, the formula we know, that is integration 0 to pi, and this is normalized function. Okay, 0 to pi psi star h dash psi dx, right? This is the formula for one dimensional infinite. This is the formula for the ground state energy correction in the ground state energy in first order. Okay, so now we'll put the value here. It is going to be integration 0 to pi root 2 upon pi sine pi x. Value of h dash is given, right? This is ax. Ax into root 2 upon pi sine pi x dx. Sin x, sorry, because pi got cancelled. Sin x. sin x, it is also sin x dx. So now it's an integration, we can easily solve. So this is wait, so we are finding the correction is the, okay, just wait, let me check. This system is hanging. Just give me a bit. So we need to find out correction to the ground state energy to the first order in U. Okay. So it is going to be now 2 upon pi integration 0 to pi. This will get cancelled. So it is going to be x sin square x dx. Okay. We'll solve it by integration by part. Very simple. So it is going to be okay. So yeah, it's going to be 2 upon pi, and a is also there, 2a, because a is there, right? So after solving this, this is going to be a pi by 2. This is the answer. Okay. And which option is matching? Option number A is the correct option. Okay. So a pi by 2 is the correct option. Okay. Now I'll tell you the trick. Okay. I'll tell you the trick. Okay. So here this question is given that perturbation is given h dash equal to ax, right? So since perturbation h dash equal to given ax, if x is there in perturbation, if x is there, if uh, perturbation is in this form and x and power of x is 1, right? In that case, what we do is we replace x and length is given, right? 0 to pi, it is between 0 to pi, right? So length is pi. So what we do is we replace x by length by 2. Here what is going to be a into length is pi by 2. So it is going to be a pi by 2. So we can directly excuse me 1 second. We can directly solve this equation easily. So it is going to be a pi by 2. Wait. A pi by 2. So this is the trick, right? We'll replace x by length upon length by 2, right? So length is pi here, so we'll replace x by pi by 2. So a into pi by 2. So this is the ground state and the correction in the ground state energy to the first order in A. Okay, this is the answer. So this is a very simple trick. Remember that, so you can easily solve this type of question. It will save your time. Okay, so we just what we are going to do is we are just replacing x by length by 2, right? Length of well by 2, that is pi by 2. In this case, pi is the that width. Okay, I hope guys you understood both trick and the question and solution of the question. Okay, so now we are going to solve next question. Next question is question number 5. This is also very good question, guys. And these type of questions, this is 5 number question which I'm writing now. Question number 5. Okay. Question number 5 is a particle in one dimension a particle in one dimension a particle in one dimension moves under moves moves under the influence of moves under the influence of the potential Vx equal to x to the power 6, where A is a real constant. A is a real constant. A is real constant for the large n. For the large n, the quantized energy level. The quantized energy level. Quantized energy level En depends on n. Depends on n as options are E proportional to n cube. Option B is En. This En, okay. En proportional to n to the power 4 by 3. Option C, En proportional to n to the power 6 by 5. And option D, En proportional to n to the power 3 by 2. Okay. Okay guys, so we'll read the question. The question is a particle in one dimension moves under the influence of the potential Px equal to Ax to the power 6. Okay, so particle which is in one dimension and which is moving under the influence of the potential Px equal to A to the power 6, where A is a real constant. For the large n, quantized energy level En depends on n as. Okay, so this is a 5 marks question. It's a lengthy question actually, but by trick we can easily solve it, right? So you need to remember the trick. I'll tell you the trick. Note down and memorize it, because and you can easily solve these questions in the examination. And these type of questions are 5 mark questions. Okay, so very important questions, and by trick you can easily solve this type of questions within 30 seconds. Okay, if you will solve it normally by integration, then it is going to take a lot of time. It may take more than 20 minutes as well. So I'll tell you the trick. Okay, so we have been given Vx equal to a x to the power 6. Here we'll check the power of, I'm telling you the trick, okay? So if I'm going to tell the trick, I'll use this one, red ink, okay, red pen. So here Vx is given a to the power 6, means we'll check the power of x, okay? So here m equal to 6, the power of x is 6, okay? Just give me 1 second, guys, I'm just checking. Okay, m equal to 6. So we'll just check power of x, okay? Here power of m equal to 6, right? So there is a trick. So sorry, En is proportional to, En is always proportional to n to the power 2m upon m plus 2, okay? So this is the trick, this is the formula we need to note down, okay? So En is always En is proportional to, this is a trick you need to write, En is proportional to n to the power 2m upon m plus 2, okay? So here we'll check this power 2 into 6 upon m plus 2, m is 6 plus 2, right? So implies E, En is proportional to the n to the power 12 upon 8, implies En is proportional to n to the power 3 by 2, divided by 4, right? 3 by 2. So which option is matching? The option number D is the correct option, right? So this is the trick formula. This is the trick you need to remember. Okay. So En is proportional to n to the power 2m upon m plus 2. Here we just if Vx is in this form, we'll just check power of x. So here power of x is 6. It means m is 6. We'll just put this 6 in this formula. So it is going to be by this En is proportional to n to the power 3 by 2. It's a very uh, easy, you can easily solve these type of questions by trick, okay? So this is a trick, note down, okay? So this is the answer. So we have solved this very quickly because of trick, okay? Okay guys.